Wow, this. You never know what goes into designing a mouse and keyboard.
He spent a lot of time and energy. They're not as simple as you might think. So when I first started here 9 years ago, I thought, how hard can a mouse be? And then you get into it and you realize every detail matters.
Now, when did Microsoft do its first mouse?
I think our first mouse was in the 80s.
Okay.
Late 80s. So, but
and why didn't Microsoft get into hardware?
Actually, the beginning was the graphical user interface. So mice was, our whole foray into mouse was because we were going to do a graphical user interface and we needed a tool to interact with the computer, and we just didn't trust that the industry would have one. So we sort of did our own. Should be somebody in here. No, it does work. This is our reliability lab.
Great.
We have to go find our tour host.
Okay.
Why don't you take a little break? And
All right.
Find the tour. Back on again?
Hold on. Okay, we're back.
Okay, we found the tour guide. Pavan, this
Cool.
is your lab. Tell us what you do
Hey,
here.
Robert.
Hey, how are you doing?
Welcome to the Hardware Reliability Lab.
Yeah.
And what we do here, essentially, my lab and this group here is responsible for identifying and mitigating product-related risks. So we look at how a product is built, manufactured, shipped, stored, used in customer hands. And our goal is to make sure the product lasts for however long we would like it to last. To that end, we design mechanical functional tests, environmental tests, reliability tests. These tests can be.
So you're the guy who's paid to spill Coke on his mouse, right?
That's right. Breaking things. It's a fun job. It's a fun job. Breaking them is not hard. Fixing them is the hard part.
Yeah.
That's where we task Erik's group and the mechanical engineers to, former Erik's group, to suffer that. But further understanding how a product performs and how customers use it is critical. That's kind of like where our work starts, to understand use scenarios and how people deal with them.
Okay.
Once we understand that, our next step is to define tests and test methodologies.
Show me around the lab.
those.
Show me what some of the equipment you have here. 'Cause you have quite a bit of equipment.
I'd be happy to show you. So once again, in terms of how we do testing, we have this multi-view view of the world.
Okay.
So when we test a mouse, for example, a mouse for us is a final system. There's subsystems that go into a mouse. So a regular mouse like this, for example, this is a ball mouse, but there's a ball subsystem, for example, within the mouse. Most optical mice, here's one in pieces. But most optical mice, for example, they've got a wheel subsystem. You've got an optical tracking subsystem down over here. So the way we look at reliability is we don't want the final mouse to be just reliable. We kind of take a bottom-up view where we make the individual subsystems reliable, for which we make the actual individual components on the board reliable, and then we test a mouse at a mouse level. So it's kind of like the multi-view world. For example, here what we have is a RAM optics microscope we use for some of our optical chips. So the hardware group actually designs our own optical chips that we use for optical mice. And it's critically important for us to make sure these optical chips are performing the way they do, are designed and built the way they do, where we expect them to be built. And so what we have here is field analysis.
Now, how do you define what reliability means?
Well, great question. I think there's many ways to skin that one. It's going to be hard to give you one right answer. But a simple way to be looking at reliability basically is at time zero, a product comes into a customer's hands, when it's made out of the field, performs in a certain manner. After 5 years of use, we want the product to essentially perform like it was on day one. Or how a product degrades over time is essentially an understanding of how reliable it is.
Right.
So clearly, expectations are set with the. There's also another ASQ, the American Society of Quality. They have a definition around reliability, and that's creating unexpected customer outcomes. So if a customer has a certain expectation for how a product performs when they buy it, it's essentially being able to hold true to those expectations.
Right.
So there's many ways to it. But for us, for quantitative terms, it's understanding how it performs at time zero and understanding how that performance changes over time.
Now, so reliability doesn't include spilling a Coke on your mouse.
Yes, it does.
Oh, it does.
It does, because that's customer outcome. So if people spill Coke on their mice all the time or keyboards all the time, and these products are being returned to us, that's something that's important because we would like to be able to avoid people having to return product and have sort of an unexpected or unsatisfactory customer experience.
Okay.
And because there's design things, to be able to fix that problem, you have to do a bunch of mechanical engineering things, for example. So it's our job to be able to define those requirements to help the design engineers understand what they need to be doing to solve that problem.
That must be a weird meeting. What kind of things can we plan our customers on doing on our hardware?
This is a simple one, but this is a hard one to solve. We do what we call a chemical withstand test.
Alpha-hydroxy?
Yeah, so we take a mouse, for example, regular painted product, and we apply a host of chemicals that we think people commonly will use. So these include, like Erik was just saying, cosmetic products. It can be lotions, perfumes, alpha-hydroxys of different types. It could be cooking oils, Coke, coffee, the regular works. So, for example, when a part degrades, or when paint peels off, or when you get staining because of one of these things, it's a relatively simple use scenario. So people touch the part, and over 3 years or over 2 months, the paint degrades or the paint changes color. It's a rather unsatisfactory but easy to tell customer experience, but it's a hard problem to solve. It means that you understand paint chemistry, you understand how things react, what's a pigmentation, what's carrier, what's base resin, what's acceleration factor, what the right test limits are. So sometimes getting the apparently easy things correctly is a little hard. So, yeah.
Just a little.
That's a little hard, yeah. Some people spend 3 years trying to fix that.
So you guys build your own silicon here?
We don't build the silicon per se here, but we design the silicon. We have a group within the hardware group that's actually responsible for designing our optics and navigation systems, and we oversee the manufacturing and development of these, and obviously we take care of them being used in our mouse products.
Wow.
But yeah, we've done that for several years now, can't we?
Yeah, 4 years.
4 years now.
We're the only other mouse company. We are the single mouse company in the world, other than all the other guys out there that don't do our own silicon.
Right.
Yeah, and that's one of the cool things, because we build the thing ground up, so we can build, innovate, and develop on top of that, because we essentially kind of build the actual underlying technology.
Right.
So yeah, it's a great platform for us.
Very cool.
Yeah, it's kind of cool.
All right. So what else is going on here?
So all kinds of interesting stuff. So did you guys get a chance to look at this thing here, Eric? No. Okay, so I'll leave that for now. We have a couple of these going on over here. Oh, here we have what we call an abrasion tester. So this is a simple example, once again, of what's important. You use a product for 5 years, if the logo goes away, does that matter? For some people, it's a sign of a poor product. So we do, when we test and we put things on there, we pad print our logos, we do abrasion tests, we do chemical tests, we do mechanical wear tests, to make sure that things just don't change over time.
Yeah.
These are simple cosmetic things, but have sort of a perception in terms of quality for a user.
Yeah.
But we do a lot of hardcore testing, which relates directly to the actual performance of the mouse and how it's behaving. Here, for example, is an interesting example. So, for example, what we have here is a button life tester. It's actually what it's doing is characterizing how a button feels. And the characterization is really in terms of force and displacement.
Okay.
Or force and time, as in this case.
So it's putting pressure on the mouse?
Yeah, it's actually moving down about 0.5 millimeter per second, so it's a little hard to tell. Okay. But it's actually traveling down real slow and coming back up. And from a reliability standpoint, this is important because this essentially tells us how a part is performing at time zero. So like I was telling you earlier, the important thing for us is to baseline how it's performing when it's brand new and make sure the thing doesn't change over time. This is an important baseline for us, is how it's performing when it's brand new. This is a piece where we actually work with, so I guess he saw the ID lab and the Ergo lab. So this is where we work with Andy Carvel's group and guys like Dan O'Dell and Jake. Because from a usability standpoint, people would like it to feel a certain way, would like it to sound a certain way, and there's a comfort zone. And we actually help them sort of quantify and establish these metrics, so when people say they like it, we understand what it really means.
Robert was talking about how he likes his keyboard to sound a certain way, and he's one of the users that has a strong
Yeah.
opinion.
Yeah, that's important, yeah.
This is how we measure things.
This is how we measure them, yeah.
Feel.
Feel. So feel is,
So if your mouse starts feeling mushy, you didn't do your job right, huh?
right.
Well, now we know who to blame. You didn't test it enough.
We see a lot of mushy mice, but we try not to let them get out there. We have to fix them before we send them out.
Yeah.
But this is the first piece to it, though. This is essentially quantifying that performance.
Okay.
And the second piece is that noise you hear behind you, is where we actually do button life testing.
All right.
I can walk you back there real quick.
Okay, go.
Hey, Lowell, can you set up a Nova and MTF test real quick so Rob can take a look at it? Okay, really? Can you just run the Nova also? Thank you. So here we have, it's real noisy, and that's why we have to go shut. But, so the second piece, like I was telling you, the first step was to make sure we understand what the curve looks like, to make sure it's feeling correctly. The second piece is this. We'll take a mouse, for example, and take its buttons and run them through millions of cycles of operation. Typically what people do for a 3 or 5 year period, and then we go back and periodically test them on that machine to make sure the feel hasn't changed. If the feel has changed, we go back to the mechanical engineers and tell them, hey, there's something wrong with the key switch. Sometimes there can be something wrong with the component. But our goal is to be able to identify and fix these problems during product development, so that when the thing ships, it's kind of good as new all along. For example, yeah, there's one more behind you. For example, when people are using wired products, essentially, as you kind of whiplash your mouse day in and day out, what you cause is essentially strains that point, the relief point, right over there. So there's a chance the cable can break. We definitely don't want a customer to run into a broken cable, so we'll test these for once again tens of thousands of cycles prior, and then figure out once for sure the cable's working. And what I have here is a bunch of temperature humidity chambers. So this is where we do what we call the shake and bake. So most of our products, before we ship them, let me see if I can let you see this. Yeah, I can let you see this part here. So what we have here is what we call subsystem level testing. We have a bunch of PCBs with components. And I'll give you a 30-second on the whole philosophy behind this. The idea is when you have a mouse and use it for 5 years, as a test engineer, what I need to be able to do is to find a way to extrapolate how a mouse will perform over 5 years without taking 5 years to test it. So I need some means of accelerating the performance of the behavior of the mouse through a shorter period. Typically a three-week period, a 4-week period, and so on. And so this process is called accelerated testing. This whole idea of taking a stress that typically happens over a 5-year period, sort of compressing it into a 3 or 2-week period. The best known means for accelerating performance is temperature and humidity. So how a product performs, a piece of plastic, for example, how a piece of plastic will degrade 5 years from now can be relatively well understood if you sort of elevate the temperatures and use a lesser period of time. So we go up to pretty high temperatures, well above what most people will ever kind of use the product for. But the purpose there is not really to see how the product will perform when it's melting, but really to understand how this tells us, what this tells us about how a product will perform 3 years from now.
Right.
So so we do temperature tests at very high temperatures. We dive down to really low temperatures, like minus 30, 40 degrees. We use pretty high levels of humidity. Here I have, so for example, the pieces that you saw there were subsystem level. They were just components.
Yeah.
What I have here is the final system level. So this is like the whole mouse put together. This is a mouse that we've been shipping for a couple years now. But the idea being, once again, that we're interested in how a system performs, how the subsystem performs, and how the actual components perform.
Okay.
So that's kind of like what these
I'm
chambers.
staying close to you just so I can hear you.
Sure, no problem. No, I'm not too afraid. What we have here, a couple of other systems. For example, here is something that we use for testing our wheels. Before we ship a product out, obviously we'd like to make sure the wheels last. So we test them for several hundred thousands of revolutions on gang testers like these. We have a couple of these here and a couple of these downstairs. It gets kind of noisy, so we kind of keep them out. But the purpose here, once again, is to test all mechanical functioning aspects and solid-state aspects of a product before we ship it out. Back here we have, they're not running right now, but these are essentially what we call highly accelerated life test chambers. What they do is to mechanically induce stresses thermally with humidity and also via vibration and so on. So we kind of rock and shake the thing as well as increase temperatures. This mimics how things get shipped, how they stay in storage, how they're on a boat from China, for example. The purpose is to mimic those kind of use environments to make sure it lasts.
Very cool.
So that's kind of like most of what we do here, isn't it, Erik?
Really neat.
We do also do a couple of virtual tests, do simulation and so on, but those are kind of hard to have as physical demos, but they're essentially pieces of
Now,
software.
how long do these tests run? How long will you?
They run for millions of cycles worth operation. So sometimes it can be 10 days, sometimes it's 30 days. For a keyboard, it's a lot longer because the number of cycles is a lot longer. So it can vary.
All right, let me change tapes here because I'm almost out. So my tape, we just came off a tape change. Just
Okay.
So I understand.
What we do typically is to test every one of our products before we ship them out into the field.
Yeah.
So we do functional testing. So our goal is to make sure our mouse works. So we test all the buttons, we test the optics to make sure it's working, we test the wheels to make sure they work. And this is sort of a flavor in terms of what type of testing we do. Every one of these products that we ship off, we make sure the buttons work, we make sure the wheels work, we make sure the optics track correctly. And this is something we've done from the very first mouse we've shipped, right?
Yeah.
And our test systems grow more and more complex as we add more features and functionality to our devices.
Now we have RF mice, and that makes it
Now,
more
obviously, this
complicated.
isn't the only test machine in the world. There's probably
This is the simplest and the oldest, obviously. I wish I could show you the cooler stuff, Robert, but I can't.
I know.
But we do our, like Erik was just saying, our newer test systems, they can do our RF testing and wireless range testing and throughput and performance. Essentially, our goal is to make sure each one of these mice is performing the way we would like it to before we ship them out.
So how many on the factory floor? Because the mice aren't made here, right? They're made in various factories
Several
around the world.
places. Yeah.
How many mice can a machine test in an hour?
So there's
Probably a pretty high number, I would guess.
Yeah. There's a lot of test equipment. We have another group that just spends their life designing, testing, and deploying test equipment. So there's a lot of stuff. I think.
I don't even know how many. Hundreds of those tests.
Hundreds of them, I think, being used, and there's always a couple of spares, a couple of downs, or a couple being refurbed. So yeah, we have a ton of lines. I'd say every line at least has a couple of test equipment. So yeah,
Pretty cool.
yeah.
Very cool. Well, thank you
that's
very
what
much
we
for
do.
the tour of your lab.
Thank you.
Is there anything else that is cool about this? Or?
Yeah, the people around us. But they're not here, unfortunately, right now. They're busy working, thankfully.
Yeah.
Yeah, I think it's fun overall. And,
Cool.
it's
Thanks,
useful.
Bobbin. Appreciate your time.
Thank you.
Okay.
Thank you.
We're heading downstairs now and have a look at the model shop, or at least perhaps aspects of it.
Okay.
And we'll take a little break as we head downstairs.
Cool. Thanks.